All right, let's look at scientific notation. Scientific notation is a shorthand and we're able to write large numbers. So here's how it works. Let's say that we have a times x to the n. For this to be in scientific notation, a has to be a number that is at least 1, but it has to be less than 10. And this should not be x to the n, it should be 10 to the n. And n needs to be an integer. That's a positive or negative whole number. So as an example, I'm going to write down some numbers and you tell me if it's scientific notation. 2 times 10 to the 5th, is it or isn't it? 0.2 times 10 to the negative 3rd, is it or isn't it? 4.12367 times 10. And let's go with negative 1.4 times 10 to the 8th. This first one is scientific notation. The 2 is at least 1, but less than 10. It's being multiplied by 10 to an exponent, and the exponent is an integer. The second one is not scientific notation because this 0.2 is not at least 1, it's less than it. This third one is scientific notation. The number at the beginning is at least 1, it's less than 10. Multiplied by 10 to an exponent. The exponent is not written there, but it's a 1. The fourth one is not scientific notation because it is negative, and it needs to be positive to be in scientific notation. All right, let's do an example. Which of the following is equivalent to this ungodly number? Well, you'll notice first of all this is 3.64. These are all 3.64. Nothing to look at there. The only thing that's different with these answers are the exponents. If your original number is bigger than 1, you're going to have a positive exponent. If your original number is less than 1, you're going to have a negative exponent. This original number is bigger than 1, our exponents cannot be negative. These are really tiny numbers. So, to figure out what this is in scientific notation, you take your decimal point and you count how many times you move it to get to the 3.64. 1, 2, 3, 4, 5, 6, 7, 8 times. Therefore, this is 3.64 times 10 to the 8th. Number 2, the distance from our solar system to the nearest star, can't even pronounce that, is 2.49 times 10 to the 13th miles. The distance from our solar system to the next closest star, alpha something, is 2.56 times 10 to the 13th miles. How much closer to our solar system is the closer star? Well, to do this problem, we're going to have to take 2.56 times 10 to the 13th minus 2.49 times 10 to the 13th. Subtract those. Now you can treat the 10 to the 13th kind of like a variable because we're multiplying that. You can factor out that, since it's in both terms, and you're left with 2.56 minus 2.49. If you subtract those, you're going to get 0.07. Now the problem is 0.07 times 10 to the third is not scientific notation. So we're going to have to move this decimal place 2 places to the right to get a whole number 7, 7.0, or the answer is just say 7. When we do that, this 10 to the third is going to get smaller by 2 movements. So 3 minus 2 is 1. So it's going to be 7 times 10. I'm sorry, this was supposed to be an exponent of 13. 13 minus 2 is 11. So we get 7 times 10 to the 11th. Another way to look at this, people get confused. If I move left, am I adding the numbers to the exponent? If I move right, am I subtracting? Which is it? It does get confusing. So here's how I actually do it in my mind, because I get confused also. So let's just leave the 10 to the 13th. Just focus on this. 0.07 means 7 hundredths, which means 7 times 1 over 100. 1 over 100 is the same thing as 100 to the negative 1, which is the same thing as 10 to the negative 2. Maybe I went too deep into the rabbit hole there. Now at this point you're multiplying the same base, add the exponents, and you get 10 to the 11th. Alright, come and see me at my desk if that is just overload, and I will be happy to try to explain that better. Excluded values. These are numbers that you cannot use into the problem because it makes the problem undefined. So mainly for us it's going to happen in 2 different locations. You don't want your denominator to equal 0. My handwriting is taking a turn for the worst. Your denominator cannot be 0. So for example, if we had a problem like 3x over x minus 4, our excluded values would be x equals 4. X can't be equal to 4. Because if you put a 4 in here for x, 4 minus 4 is 0. Can't happen. Also, excluded values happen if you want to use just real numbers. You don't want your evened root radicand. I'll explain what that means in a second. You want that to be bigger than 0. So you don't want it to be less than 0. So even root means that this is either a second root or a fourth root or a sixth root or an eighth root. The radicand is what's on the inside. If you take an even root of a negative number, you get an imaginary answer. So we want the answers in here to be positive. Let's look at the first example. For what values of x is this undefined? Well, these things undefined happen in 2 places once again. Even root radicals, which we don't have any, and fractions, which we do. Take your denominator and you set it equal to 0. You get x by itself, and this tells you what x can't be. X cannot be 0. If you're still not sure when you get to the end, maybe there's more, maybe I'm missing something, take these numbers and plug them into the problem. If it ends up being undefined in your calculator, then that means it's an excluded value.